Hello, grade 8. This is lesson 1.5. It's all about what's called the Pythagorean theorem. Now it seems a little complicated just in its title, but it'll come. There was a guy named Pythagoras. He lived, he's born about 570 BC. And he was a philosopher, politician, all sorts of things like that. So 2,500 years ago, approximately, he lived. And he came up with this idea, this theorem that essentially makes it so that you can, if you know the side lengths of a triangle, you can determine whether that triangle is a right triangle or if it's a different type of triangle. Exactly. So even if the measurements are close, it could actually say whether it is or isn't exactly. Or if something is a right triangle and you know two of the sides, that you could actually calculate what the other side is precisely. So the first thing to know about this Pythagorean theorem is this formula over on the side here. What it says is there's one side of the triangle that if you square it, so you multiply it by itself, it will be equal to the other sides squared plus the other side squared. And we're going to look at which sides it's talking about here. But what you need to know is it applies to right triangles only. So right angle triangles or right triangles only. Okay? It doesn't apply to the isosceles where two sides are equal length and one isn't, unless there's a right angle somewhere in there. It doesn't apply to equilateral triangles where each side is the same length, because equilateral, these will always be 60-degree angles in here. And it doesn't apply to scalene triangles exactly, unless there is somewhere in there, a right angle. So it is for when there are right triangles. So let's look at this triangle right here. We've got a right angle in the corner. Because these meet at a 90-degree angle, they line up with our grid paper in particular. Then we have another line segment here that connects the end of this line segment to this line segment. So right here we formed a triangle that's known as a right triangle. Now, if we've got this angle right here that's a right angle, the line that's opposite, the line segment that's opposite to it, we call it the hypotenuse, which means it's opposite side of this right angle. And the other two we call leg and leg. Now often the hypotenuse will use the variable h, and these legs, the one that's further to the left we often call A, and the one that's further to the right we call B. Not always. The legs could actually switch back and forth. It doesn't really matter within a single question which one you decide is A and which is B, because you will get to the same answer. But typically some say that they put A left, B right, or some say the bigger one should be B and the smaller one's A. It doesn't really matter if you get these two flip back and forth, as long as you stay consistent through the whole problem. Whereas this hypotenuse being H, we need to keep that consistent. Some people also will use the variable lowercase c instead. So we know that it applies to right triangles. That's what the Pythagorean theorem applies to. And also that this word hypotenuse refers to the one that's the opposite of the right angle. All right, so let's look at this example. I've drawn a triangle here. I've drawn a triangle that is, it has a height of 3 and a base of 4. So this side is equal to 3. This side is equal to 4. And before we were drawing squares off of it, right? We were taking a squared. So a squared would be 3 times 3, which is 9 units squared. So that's what a squared is. And we made another square off of here, so 4 length, 4 height. And we get 4 squared, also known as b squared, is 16 units squared, correct? Now, earlier in the unit, we were doing this thing where if we had a square off of here, so we had this line that was 3 and 4, so we went 3 and 4, 4 and 3, 4 and 3, and we made this square off of there. See, it's a square. And then we had to calculate, you know, this is 1 unit squared. And then looking at this, we've got 3 and 4. 3 times 4 is 12, divided by 2 is 6 units squared, which means each of these is 6 units squared, 6 units squared, 6 units squared. And if we add all of that up, we're going to call this C in this case. Sometimes you call it H for hypotenuse, sometimes you call it C. If we add all of that up, all these areas, we have 6 plus 6 plus 6 plus 6, also known as 4 times 6 is 24, plus 1 in the middle is 25. So C squared is 25 units squared. And what the Pythagorean theorem states is this side, the hypotenuse squared, is equal to this side squared and this side squared. So in this case, 5 units, if we square that, and remember, we're not just squaring the unit, we actually have to square this number. We get 25 units squared equals 16 units squared plus 9 units squared. And if we take our 16 plus our 9, it is 25 units squared and 25 units squared. Isn't this guy a genius, Pythagoras? He came up with this idea that if you square this side, you square this side, the area of the third side, if it's actually a right triangle, will always be the same as those two sides squared added together. What about this? For A, instead of having the hypotenuse squared, the C squared being what we're looking for, we're now looking for B squared. So hypotenuse squared was 100, A squared was 36. And if we use our formula C squared or H squared, whichever you decided, I'm choosing C. C squared equals A squared plus B squared. C squared was 100. A squared is 36 centimeters squared. B squared is what we don't know. We just flip them into the formula, switch in the numbers we have. Just remember last year's math where you were taking away from one side, you have to take away to the other. And we're taking away 36 from here because we want B squared on its own. So we take away 36 from both sides and we end up with 64 centimeters squared on this side. These cancel out and we're left with B squared on this side of the equal sign. And so we found out that B squared was 64 centimeters squared. That means the area we're looking for is 64 centimeters squared. What about 5A? 5A right here. Now, instead of finding the area here, we're trying to find this side. Now, it's the same steps we took in part A, 3A and 4A, except one step new at the end. So let's look at this. We need to figure out this area squared and this area squared. We need to add those together. And then we need to do square root. So let's look at this. H squared is what we're trying to find out. I've been using C squared before, but H squared is what I've decided this is going to be called. The variable doesn't matter as long as you keep it the same through that whole question. So H squared equals A squared, which is this one over here, plus B squared, which is this over here. So to square a number means to multiply it by itself, right? So 8 centimeters times 8 centimeters plus 6 centimeters times 6 centimeters. 8 times 8 is 64. So the square off of here would be 64 centimeters squared. And the square off of here, 6 times 6 is 36. That would be 36 centimeters squared. 64 plus 36 is 100 centimeters squared. So H squared, I'm just going to erase this because I did a step in here where I added in some drawing. H squared equals 100 centimeters squared by adding those two. How do you get H if you have H squared? Remember, if you square root a square, those cancel out. Whatever we do to this left side of the equal sign, we need to keep it equal by doing it also to the other side. So there is square root of 100, which is 10, and square root of centimeters squared. Square root of a squared leaves just that unit, so it's 10 centimeters. So if you have a triangle that this side is 8 centimeters, this is 6, this has to be 10 centimeters. There's a few ways you can do this question, but I'm just going to use the same process we used in question 4a and the previous questions, and we're just going to do some subtraction instead. You can rearrange formulas, but we'll do that in a later lesson. Here, there's a side that's 15 centimeters long, there's a side that's 12 centimeters long, and there's a side that we called L this time. Instead of A or B, we're calling that leg L, handwriting L. So we know that the hypotenuse squared, 15 times 15 is 225. We know that it is equal to each side squared, right? So 12 squared, also known as 12 times 12, is 144 centimeters squared. So that's 144 centimeters squared. This one off of here is 225 centimeters squared. And we know that this, if we subtract this from it, which is what we're doing here to get rid of it, we'll be left with our L squared. Or in other words, we subtracted 144 centimeters squared from this side to move it over to the other side, okay, and to leave this alone. So we're left with 225 subtract 144 is 81 centimeters squared is equal to L squared. And to get rid of the square, to figure out the length of that leg, we square root both sides. Square root of 81 is 9. Square root of centimeters squared is centimeters, and we're left with L. So L is 9 centimeters, which tells us that this is equal to 9 centimeters. 7a, similar thing. We've got a triangle here, 3, 7, what's the hypotenuse? I believe it assumes that this is a right angle here. Yes, indeed, I just checked and there is a right angle there. So that means these are our legs. So these ones will square and add them together to get this squared, and then square root. So one leg, 3 I've gone with. If you had these opposite sides, just like flipped, that it'll still get the right answer because 49 plus 9 is the same as 9 plus 49. So 3 times 3 is 9, 7 times 7, this side squared is 49. Add those together, you get 58. So h squared is 58 centimeters squared, square root both sides, and sometimes you don't get a perfect square under the square root sign, so you just leave it as is and go square root of 58 is what h is. So square root of 58 centimeters long, which we know that the square root of 58 is a little bit more than 7, a little less than 8, so it's going to be 7 decimal something. And some questions will say to 1 decimal place, some will say to 2. So if it's 1 decimal place, or if it's a whole number, I'm just going to write out a bunch of the decimals from the calculation. If it says to do no decimal places or to the whole number, the 6 tells the 7 to grow up, so you'd say it's closer to 8. Or if it said to go to 1 decimal place, it would be 7.6. If it said 2 decimal places, you go to this place, but the 5, the one to the right, tells it to grow up, so it would be 7.62, and so forth. So usually it's going to be 2 decimals 1 or no decimal places that it's asking for. It depends on what the question asks exactly. Just a quick recap. The hypotenuse squared is equal to the legs squared and added together. That's Pythagoras' theorem, also known as the Pythagorean theorem.